Doing. Hope you're all ready for today's class. Please introduce yourself at the comment section, your name, where you're joining from, and what are your expectations for today's regular series. I'll also be introducing the speaker of the day, Dr. Shakira Ganzafar. She's a scientist at the Pakistan Agricultural Research Council in Islamabad. She is a seasoned scientist at the Pakistan Agricultural Research Council in Islamabad since 2008. Her primary research focus is on applying AI and machine learning in microbiology, particularly in the realm of probiotics. With expertise in metagenomics, she explores microbial flora, contributing to a deep understanding of microbial communities. In her role at PARC, Dr. Gazanfar has supervised over 50 research students, nurturing the next generation of scientists. She boasts an impressive publication record with more than 100 research publications and numerous books chapter, solidifying our standing as an authority in microbiology and probiotics. Dr. Gazanfar's skill sets include microbiology, probiotics,
Hello, thank you, sir, Professor, for your time to just uh, introduce my research background here. Okay, I am Dr. Shakra Zanfar, and today I will explain uh, the topic, and the topic is the use of application, or you can say the use of machine learning in biotechnology research, right? First of all, here's a brief regarding my research background. I am senior scientific officer at National Institute of Advanced Biotechnology, Islamabad, Pakistan, and we have some research, you can say, background in our lab that we are just working on different types of, you can say, microbial flora, and then we are just working on the genomic of our microflora to analyze the best microbe for preparation of any type of product, right? So, secondly, all my research comes from Pakistan Agriculture Research Council. Here is a brief regarding some, you can say, ongoing lab activities. Right, we are just working on, you can say, let me, I think this screen is not displaying here. Let me share again my screen. Okay, there's in my screen. So our lab ongoing research activity, we are just working on the AI based, you can say, diagnostic model for improve, you can say, animal health. We also developed a machine learning model to just you can say predict yeast extract for production of any type of yeast production media, right? So this is a little bit about our ongoing research activities. So let's talk about on AI, artificial intelligence, right? AI is a branch of computer science that seems to just create an intelligent machine, right? It's just like you can say the thermodynamics is a branch of computer of physics, right? So artificial intelligence is basically it's based on the study of human behavior, such as how human brain think, how human brain learn, how human brain solve any type of issue, and this machine is also known as, you can say, expert machine as well. Okay, so there is a, you can say, terms like machine learning, deep learning in the AI as well. So what is machine learning? Machine learning, or you can say machine, is a application of AI where we just feed the data to the machine and then allow the machine to learn and to predict something by themselves. We can also say that machine language is a subset of, you can say, machine learning is a subset of artificial intelligence. On the other hand, deep learning is a specific candidates deal about classification, clustering, and prediction. But both machine learning and deep learning provide need, you can say, high accuracy data. But in the deep learning, the difference that the algorithm where we use in deep learning are made up of neural network, basically billions of neural network related into the deep learning, right? Okay, so there's a, you can say, difference between machine learning and deep learning. And in the machine learning, here will be just a feature extraction and classification is basically based upon our own. But in the deep learning, we had just, you can say, a merge huge data of neural artificial neural network and then predict the result of our own quantity, right? So for AI, we just need different types of, you can say, things to understand these things. I have just list down this trend, like we have to just understand what is algorithm, what is data information, what is human, and how human use this, you can say, information. Then at the end, what is program, right? So what is data in AI? Data is AI. Data is information background of the you can say artificial intelligence. If a fake data, then the result, or you can say AI models are fake. So original data should be there to just predict, you can say, AI model, right? If data is not good, your AI model will not give any type of, you can say, result. After data, you have to just use you can say term data mimicry. For this information, you have to use the hidden information from the database to predict any type of, you can say, desired information of your own side. So what are the algorithm in AI? Algorithms are just like, you can say, instruction that allow our calculation, or you can say other operation. So our algorithms are building block of AI models. An algorithm is a program that tell any researcher that how computer, you can say, learn operate on this algorithm. With the algorithm, you can say no AI. So there are three different types of algorithm like supervised learning, unsupervised learning, and these learning just use different types of algorithm to, you can say, predict the problems related to any type of search. So term number three, neural network. What are neural network? It's a backbone of the, you can say, deep learning. A neural network is a method in our artificial intelligence that just teach computer to perceive data in a way that inspired by a human brain. So in machine, a neural network is a model inspired by the structure of function of biological neural network in animal, you can say, brain, right? Just like example of neural network in a chat GP, they just use a billion of, you can say, neural network to just achieve their goal of thinking, right? So there is a difference between artificial neuron and a biological brain. Artificial brain or biological brain, or you can say, is a comparison. His slide just tells that there is a dendrite swell, and in the artificial brain there is a input, and in the, you can say, biological brain, they just is a copy paste of the cell nucleus, and in the artificial brain he's mentioned that there is a node, and the concept behind that is that the scientists just use the concept of neuron. Neuron is you can say main thinking material in our brain. So scientists just copy paste the neuron thinking, and they just build a artificial brain, and then this artificial brain having the, you can say, billion of neuron network, and combine this, you can neuron work and give rise a question of your research problem. So comes to the main topic of today topic, you can say, discussion, that the machine learning in biotechnology. What is the role of machine learning, or you can say ML, in biotechnology research? So here's a very interesting topic. Like you can say that machine learning can use, you can say, different types of algorithm and tools to just predict different types of research problems, right? In biotechnology, right? Genome sequence. Number one is the machine learning algorithm can proceed analyze vast amount of genomic data, right? And then it will faster and more accurate genome sequencing, which is very much important for understanding the genetic disorder and developing target treatment to control, as you can say, disease as well. For this purpose, scientists are just using different types of AI tool to just visualize the data, and then they just built a new model to control the, to understand the genetic order and develop the different types of treatment, target treatment regarding their research program, right? Secondly, improving disease diagnosis. Biomarker discovery, another area where machine learning can help to identify novel biomarkers, which can be a measurement indicator for biological process, disease states, and responses of treatment. This can be lead to development of more accurate diagnosis test. For example, XGBoost is a library where they just give a huge machine learning algorithm to just use these and predict the biomarker, right? Okay, then secondly, personalized treatment and AI tool. Machine learning algorithm can help to match patient with the most effective treatment based on individual genetic profile and disease characteristics, improving patient outcome and risk, reducing the risk of adverse reaction. GenCode is a large general access project for annotating all type of gene feature in human as well as in mice. So by using the GenCode, you can easily, you can say, build a new personalized treatment, and you can also, you can say, use this model to predict these things, right? So there is another area where machine learning can use to just predict the, you can say, things. So another tool, CMMap and Linux, is a database which can be used to just take data from gene for a gene expression, and you people can just build a new, you can say, model to just predict a new drug and finding a new drug for existing drug to a cost effective strategy, right? So in the way we can just use a machine learning in artificial in you can say biotechnology research. So artificial intelligence for diagnosis, a good example is a Path AI artificial, which use AI machine learning to enhance the pathology by the assisting fast diagnosis by histopathology slides. So it's a very unique and you can trusting tool which you in which you just provide the images and you can build a new model to predict any type of you can say a disease. So another area where you can use the machine learning, like enhancing the bioinformatic tools, protein structure prediction. Machine learning model can easily accurately predict the three-dimensional structure of the protein, which is very crucial for understanding the function of the protein and then the designing the target drug as well. Metabolic pathway analysis. Machine learning can help researchers, scientists, and students to map and analyze complex metabolic pathway, which providing insight into cellular process and identify potential target for any type of, you could say, treatment, right? Then part unfolding and structural biology, another area where machine learning can be a very useful tool to just predict the things like understanding the three-dimensional structure of any type of proteins are very crucial for drug designing and disease treatment. AI machine learning techniques has a, you can say, crucial role to predict protein structure accurately, and that can be very, you can say, helpful to design new drug, allowing researcher to design drug and to specifically target the protein involved in this disease pathway as well. For this purpose, alpha 4 2 RF diffusion, these are the very good example for the, you can say, prediction of the, you can say, three-dimensional structure prediction of the protein, and then to build a, you can say, accurate you can say drug designing for your research as well. So after that we have a just a mini, you can say, proof whether and how machine learning model can build and can, you can say, search the drug discovery, right? So here's a, you can say, brief drawback of the traditional drug discovery. If there's a no machine learning, what will be the happen? Almost 10 to 15 years will be take for a discovery of any type of, you can say, uh, a drug. Do you know that there is a silent pandemic on global car antibacterial resistance, or you can say AMR? Every year is more than 70,000 plus people die due to the drug resistance, and almost 2.5 million people get an AMR infection. If no action take place, an AMR can, you can say, give a almost 10 million death, which is more than cancer every year by 2015, and this statement given by WHO. So this area can be covered with the help of, you can say, machine learning. We can predict the new AMR resistance type cassette gene to build a new drugs as well. So here is a problem that the example of machine learning project in drug discovery is that here's a research gap. Million of compound are untested. Reason that lack of desired property compound. So with the help of, you can say, AI, you can filter these untested compound from different types of zinc database or other thing database to find best compound with your desired property, like binding energy of the compound, IT50 value, binding compose, attraction of the compound. So with the help of machine learning algorithm, you can easily analyze the biological data to identify potential drug target, right? So these potential drug target predicting the life to model predicting with specific biological target, right? So machine learning model can also help to analyze the large data set to predict the biological activity of the compound and accelerating the drug discovery process. What is the result? Result is that by using machine learning, we can design a model or your model molecule with our desired, you can say, property. So you can design a molecule with your own desired property with the help of machine learning. Without machine learning, you can't, you can say, predict, or you can say locate a exact molecule with your own desired properties. So there's a different types of, you can say, AI tool which you people can use to just build machine learning model and then predict a new compound for prescription development of new drug like Articator, DeepChem. These are the open source, you can say, methods where you can provide data, you can take data and then play with data and you can say just take a unique compound from this data. Here's a you can say brief research where they just use, you can say, machine learning, you can say, as you can say, models. Scientists use machine learning or deep learning AI model to just you can say discover a molecule which having to just scientists use, you can say, machine learning to see structure of the AMR resistance bacteria, then see how this bacteria attack to the structure and then make a new antibiotics to treat, you can say, challenging you can say disease. So with the help of AI, they develop a narrow antibiotics which can you can say break down for a scientist to build new antibiotics within a years, rather they are just waiting for you can 10 years to just give new antibiotics or you can say new drugs in the market, right? So for this purpose we have to see what types of different types of process which you people can use in your research and build a new, you can say, machine learning model to prepare new drug, right? Here's a material method. Here's a brief, you can say, model where you can just people just learn from, you can say, from courses and learn from literature how to use these steps to build new model for preparation new drug. Like in step number one, you have to define a problem in your lab. If you're working on the you can say new drug discovery, then new cell wall inhibitor, it will be the positive set and non-cellular inhibitor will be the negative, you can say, data set. You have to take the data collection from you can say data collection, and data is a fuel for machine learning. So from already compound, you can say, available compound like penicillin used against pseudomonas or the C pathogen from your lab, billion of drug for testing. So according to your data, you can just build split your data positive and negative control, and then you also use a UCI machine learning display to your data, then feature extraction and feature selection, and then split your data, evaluation your data, and then model. You can say build your model online by using different types of, you can say, online tools, right? So in the step number one, related to the new compound of new drug prediction, you have to take the data from web site like UCI data for machine learning is a portal where you can get different types of data to use for your research. And then on the other hand, if you just working on your own, you can say things, you have to see that you also use your lab data as well. If you are working on new drug, you can use things from drug bank, data bank, lab raw data, and then compile this data and then give this data in your own site, right? After that you have to select the feature selection and feature extraction. RD-Kit and Pedal tool can be used to just extract different types of feature according to your own you can say research requirement. You can build your file for further you can say analysis. And the step number three, it's feature selection is the things where we can you can reduce the original number of input data and use training machine learning model, right? Instruction to generate new features starting usually from very large set of input features, your own desired you can say feature that can use regional feature as well. They can prove over the learning process as well, right? After feature selection and feature you can say extraction, you just use the step of 4, 5, 6, where we have to split the data evaluation and data training by using Vika non-coding model. Vika is an, you can say, very good, you can say, non-coding model where you can just build a huge, you can say, innovative type of machine learning model and AI model, where you can say without any type of you can say difficulty. So entire data set split into the independent and dependent variable, with the former being just x and later into y. So after splitting your data 20% testing and 80% remaining on trained data, you can just build a new model, and uh, the data will give a unique result for the prediction of a new drug, right? So after that step number 8, you have fitting the model by Vika as well. So here is the example where you can just build a, you can say, model to using different types of things, right? So for all this purpose, you have to use Python language and Anaconda, and then after that adding different types of code, you can just build your own machine learning model as well. So here's a few result of our own machine learning. There we have some, you can say, active compound regarding the cell-wall inhibitor and non-active compound, and these are very good example to build a model. Here's an overview of you can machine learning model to predict a new drug. Here's a just a data retrieved from the drug bank, you can say zinc database, and then reprocessing of your data, then data splitting, model fitting, and model evaluation, right? So after that, you can just if you have a good, you can say, knowledge of that, you can provide your commercial service of your machine learning built model. You can publish a paper, and you can produce a number of cost effective novel drug is your machine learning model is novel, right? So as a brief, you can say a tool already used in drug discovery, and I already told the brief camp and the deep nature camp, and alpha fold deep text and head doctor. These are tools which are just machine learning based tool, and your, as you can say, discovery, or you can say the investigation process will be speed up with the help of, you can say, these magical tool to just predict a new drugs. So here's a brief of some already prepared, you can say, tool in our lab as well. So here I just gave few, you can say, machine learning model and framework for some beginner students as well. Here some I just mentioned some, you can say, background reading for some students as well. I have given some online resources for your background study, and here some online resources continue. And at the end, I am just saying that without machine learning, you people can't discover a new, you can say, you can say, drug to control different types of infection all over the world. As I already told you that with the help of, you can say, machine learning, you can easily, you can say, identify a new drug, drug to control the AMR resistance, or you can say other things. Without machine learning, people can't search out a huge, you can say, untested compound from different types of database. So by using the machine learning model, machine learning algorithm, and deep learning models and deep learning algorithms, you can easily identify a unique, you can say, compound to build a, you can say, drug for your own research area. So here is a brief regarding, you can say, machine learning application in the biotechnology research. Hopefully, you people just have an idea read regarding this machine learning magic to just search out, you can say, a new drug for mankind. Thank you so much.
Thank you everyone for joining. Can you all hear me? Can you quickly drop it on? We are willing to take your questions. Can you all hear me? If you can you please comment in the comment section, please? Can you please drop a comment in the comment box if you can hear me? All right, thank you all for joining today's webinar series. We'll be dropping also the slides she used for the presentation. And we hope to thank you so much.